Imagine it's a Tuesday morning on a busy university campus. At 8 a.m., a science lab projector shorts out. At 8:15, the library roof starts leaking. And by 8:30, a residence hall elevator gets stuck between floors. As the facility manager, you're the one fielding those calls. But a look at the monthly maintenance budget reveals a harsh mathematical truth. You only have enough money to fix exactly one of those problems today. Multiply that morning across an entire year and across a campus that manages thousands of discrete physical assets. We're talking about everything from network routers and classroom whiteboards to massive, complex life safety and HVAC systems. When an institution constantly has more broken equipment than budget to repair it, they are forced to make compromises. In higher education, the accumulation of these forced compromises is known as deferred maintenance. Facility management at a modern institution is rarely about fixing everything that's broken. It is a daily, high-stakes exercise in deciding exactly what is allowed to stay broken. A 2023 survey by Gordian shows over 60% of higher education facilities are in fair or poor condition. Institutions can only fund a quarter of these maintenance needs annually, swelling the deferred maintenance backlog to $140 per square foot in accumulated repairs. Relying on reactive maintenance, waiting for things to break and fixing them in a panic, leads to rapid financial decay. To survive, schools have to adopt strict, data-driven systems to prioritize where every single dollar goes. The first step out of the backlog is cataloging. Modern institutions deploy software called a Computerized Maintenance Management System, or CMMS, to digitally map and track the condition of every physical asset on campus. But a database of broken equipment isn't a strategy. To actually make use of that data, administrators run it through a rigid taxonomy of criticality, filtering every asset into one of three distinct tiers. The highest tier is currently critical. These are failures that pose a significant risk to health, safety, or the core mission of the school. If a fire suppression system or a main laboratory HVAC unit goes down, it requires immediate action. The middle tier is potentially critical. These are non-emergencies right now, but the data indicates they will escalate into critical, mission-stopping failures within a 12-month window if they are ignored. The lowest tier is necessary, not yet critical. These are issues that need to be fixed, but can be safely deferred for up to 10 years without halting the educational mission. This taxonomy takes the chaos of physical decay and converts it into a predictable timeline. It allows facility managers to stop reacting to today's disasters and start outmaneuvering tomorrow's emergencies. Things get much more complicated when you step outside of life safety emergencies. How do you allocate funds between two non-emergency academic resources that break at the exact same time? To remove human bias and departmental politics from these funding decisions, administrators use a multivariable scoring matrix like the one you see here. First, you evaluate urgency, how fast the asset is degrading, and assign it a 5 times multiplier. Next is impact on learning, which gets a 4 times multiplier, ensuring that core academic functions take precedence over administrative comfort. Then you factor in the number of users affected with a 3 times multiplier, followed by alignment with the curriculum and immediate budget availability, which both receive a 2 times multiplier. Let's run our morning crisis through this exact formula. We have a leaking library roof, a broken LCD projector, and a request for new science lab equipment. After scoring each variable against the multipliers, the leaky roof scores a 76, the projector scores a 67, and the lab equipment gets a 66. The math makes the decision for you. The roof definitively wins the funding for the day, while the projector and the lab equipment are moved to the deferred maintenance log. It sounds cold to reduce education to an algorithm, but when you are managing a massive physical environment designed entirely around human development, this matrix is the only viable method to distribute scarce resources fairly. While the scoring matrix feels like an exercise in cold logistics, its primary function is to protect the student. Every maintenance dollar allocated to a roof or an HVAC system is a direct attempt to stabilize the environment where education actually happens. This text from academic literature highlights how the management of spatial limitations directly correlates to a student's motivation and learning effectiveness. An optimized environment actively removes friction from the learning process. The inverse is just as measurable. Poorly maintained assets actively degrade teaching efficacy. A brilliant professor cannot overcome a classroom where the acoustics are failing, the temperature is unbearable, or the network is constantly dropping. The pedagogical resource is wasted. A university campus operates as a physical readout of administrative policy. The state of the facilities provides a tangible look at how effectively the institution's software and managers are balancing competing needs. A well-maintained campus represents the successful application of these predictive algorithms. Each intact roof and functioning lab stands as evidence of a series of deliberate, data-driven wins over the backlog. The visible achievements of students, the research papers, the degrees, the innovations, rely entirely on the invisible, mathematical dedication keeping the physical campus alive.